Hello and welcome to this episode of Math with Martinez. We are in our Pre-Cal Unit 10 where we're looking at vectors. And in this video, we're going to be focusing on vector operations. What operations exactly are we talking about? Multiplying, adding, and subtracting. Those are the different operations that we're going to see in the context of working with vectors. I'm going to show you first geometrical representations, and then we'll look at symbolic representations down below and some examples. So let's get started. Multiplying by a scalar. If you are multiplying by a scalar, what that means is that you're taking a vector and multiplying it by a single value, which we often use k to represent that scale. This will change the magnitude of your vector. When you multiply by a scalar, it's going to change the magnitude. And furthermore, if your k value is negative, really important, if k is negative, then it's going to change the direction of your vector. So here is our standard vector here, v. Now when we multiplied it by 2, notice what happened. The magnitude is that it is twice as long. And let me actually do this in a different color. Let me grab red. If k is negative, red highlighter. If k is negative, then it's going to change it and take it into the opposite direction. You can see that here, that it is the opposite direction, but the same magnitude. And then also right here, the 1/2 v is half the original, which was our yellow. See that there? All right. So that is multiplication, a visual demonstration of that. Next, we're going to have the addition of vectors. When you are adding vectors, then what happens is, like you see illustrated here in the side. If you have two vectors, v and w, and what's going to be happening if you're adding them is you're going to position them so that the tip of v coincides with the tail of w, which is that point right here. There you go. The tip of v coincides with the tail of w. And the sum is actually called the resultant, and that's what you'll see here along the side. It is the distance from the tail of v to the tip of w. The sum is that resultant. And similarly, if you are instead subtracting vectors, then what happens is just kind of the opposite of what you saw with addition. You're going to take your tip of v and arrange it so that it's coinciding with the tail of w. So that's where they coincide. And here is the resultant. All right, so that is all just a graphical representation. And now what I want to show you is the symbolic representation. So if you have your vectors in this form, that component form like we saw in our previous lesson, then if you're multiplying them by a scalar, then what you will have is the following. Your scalar k times your vector v would be that each component, let it be called A. A1 would be multiplied with that k value, and your scalar would be multiplying with your B1 value. If you're adding two vectors, then what's going to happen is you're going to take each component, the horizontal component of the two, and add them together. And you would add the vertical component to the other as well. And if instead you're subtracting, then what you would do is you take your two components that are the horizontal and subtract them, and your two vertical components and subtract them. All right, just doing a color match for what we had above. Okay, now what we're going to go ahead and do are a few examples together demonstrating both the scalar multiplication and adding or subtracting of vectors. So let's go ahead and get started. For this first one, we have scalar multiplication. We're taking the scalar of 2 and multiplying it with vector c. So what that looks like is we would have 2 times each part of our vector's components. So that would be to say 2 times, and for c, that's right here. So 2 times the -4 and 2 times 5. So that means that our resultant vector is going to be -8 and 10. That's the result of that scalar multiplication. There you go. For example 2, we are just adding our vectors together. So let me go ahead and grab a couple more colors here. We'll let this represent A. And we'll use this color for B. Okay, so what we're going to need to do here is we're going to add the components when it is written in the component form. We're going to add the parts that correspond with x together. So that would be to add your -6 and add to that the 1. And then also the y values. So that's the 2 and add to that the 7. So what is the result? We're going to have -5 and 9. That is our new vector, the resultant vector. That would be the vector that would connect the tips to tail. That third side that would look like the side that would complete a triangle. Now we're going to do the difference of two vectors. So that means that we're going to be taking and subtracting. So we would take both parts of our c vector, the x and the y, the horizontal and the vertical, and we're going to subtract from them the b vector value, so that's -1 and -7. So what is the resultant? -5, -2. And lastly, what do we have here? A little kind of combination of all of this. What we're going to be doing now is both scalar multiplication and subtraction. So what we have is we're going to take our A vector, which I'm going to go ahead and write that out. We're going to take A. Let me separate this out. A was in light blue. So that is -6 and 2. And then we're going to be subtracting from that 3 times the components of our C vector, which are -4 and 5. So let's go ahead and simplify this. That is to say negative 6 plus 12 and 2 minus 15. And what is that going to give us? We will have positive 6 and a negative 13. So there you guys have it. That is a little intro to vector operations, multiplying by a scalar, adding and subtracting vectors. If you all had any questions while watching this video, would you go ahead and take a moment to share those now? And until next time, stay fired up.